Hi everybody, this is Mrs. Pinkerton, and the subject today is 2.5 Lewis diagrams. And a key to remember about Lewis diagrams is these are only done for covalent bonds. So bonds between nonmetals. So we don't use these diagrams for ionic bonds, metallic bonds. So again, these are only for covalent bonds. And a Lewis structure provides additional information that cannot be gathered from a chemical formula, and it lets us know what elements are bonded to each other and the bond order. So if it's a single, double, or triple bond. It also tells you which valence electrons are not involved in bonding, and we call those lone pairs. So first of all, let's go over the structure of a Lewis structure. And a solid line represents a bond between two atoms. So if there's a single line, there's a bond these are two electrons, okay? So it represents two valence electrons. The dots represent a lone pair of electrons. So anytime we talk about a lone pair, we show them as two dots, and they are not involved in bonding. But they're still important to the structure of the molecule. And the letters, of course, are the chemical symbol of the element. So how do we draw Lewis structures? So there's a basic way some students are taught in general chem where you just draw dots around an element. Well, that's not hydrogen, say carbon. And then you just pair up, the unbonded electrons. We're not going to do that here. That's a simplified form. We're going to teach you the correct way to do a Lewis diagram, or the more advanced way, I should say. That simpler form works sometimes, but not all the time. So there's 4 steps we're going to do. First, we're going to determine the total number of valence electrons for all of our atoms. Then we're going to draw a skeleton structure with single bonds between the atoms, and the least electronegative element is placed in the center. Okay, so everybody's like, how do I know what goes in the center? It's going to be the least electronegative element. And don't forget that elements in the third period are able to expand their octet, which means they can have more than 8 electrons on their central atom. So this is for the central atom, can have more than 8 electrons. So what's the third period? We'll just highlight it here. So we're talking about this row, okay, right there. So like sulfur can have more than 8 electrons on its central atom because it's big enough to accommodate that. Remember, as you go down the periodic table, the size gets bigger. We're going to place the remaining electrons as lone pairs to fulfill as many octets as possible on the outside of the atom. If there are any leftover electrons, we're going to then place them on the central atom. And then we're going to make double or triple bonds to satisfy octets if all available electrons are used. So what does this mean? Let's give an example. So our first one is CH3OH, okay? So the first step 1 is we're going to determine the total number of electrons. So we have C, carbon, hydrogen, oxygen, and hydrogen again. So what I'm going to do here is, remember, this is valence electrons are 1, 2, 3, 4, 5, 6, 7, 8, right? And we ignore the transition metals. So carbon has 4, right? Oxygen has 6, and hydrogen over here has 1. So we're going to count them all. So we have 1 carbon. Carbon has 4. We have one carbon, so that gives us 4. Hydrogen, we have 1 electron times 4 hydrogens, give us 4 electrons there. And then oxygen, We have 6 valence electrons times 1 oxygen gives us 6. So we have 14 total electrons to start. So that's step 1. Step 2, it says draw a skeleton structure with single bonds between atoms. And we're going to put the least electronegative one in the center. So that would be carbon. Carbon is the least electronegative. If you were to look at your trends, you would see carbon here is the least electronegative. Remember, hydrogen and carbon are similar in electronegativity, but hydrogen only can make one bond, so we never put hydrogen in the center. So that's why carbon goes in the center. And then we're going to put oxygen. And when it's written like this, it's actually written in the order of how it's attached. So this is organic chemistry nomenclature. So each hydrogen is going to be attached to the carbon, and then this hydrogen on the end is the way it's written, it's attached to the oxygen. This is a little bit higher level one to start with, but we can do it. So we made our skeleton structure, so that's step 2. And then step 3 says, place the remaining electrons as lone pairs to fulfill as many octets as possible. So I forgot to add my hydrogens, but my hydrogens go there. So that's my skeleton structure. So right now I have 2, 4, 6, 8, 10 electrons that I've used on my skeleton structure, which means I have 4 more electrons left over, right? So now I'm going to redraw this. So I have carbon, I have hydrogen, 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 oxygen, and hydrogen. Now, remember, I can only have my octet rule, meaning I can only have 8 electrons on my central atom unless it is in the 3rd period or more. And then all my other elements have to satisfy the octet rule as well. So my hydrogen can only have 2 electrons, right? Because hydrogen's an exception. Hydrogen is here, and it has 1 valence electron, but it's in the first row of my periodic table, so hydrogen can actually only have 2 electrons, same with helium. The rest of my elements, so these can only have 2 electrons, the rest of my elements have to satisfy the octet rule. There are some exceptions like boron, but in general, that's the case. So if I look back here, I see that carbon has, well, first on my periodic table, carbon is not in the 3rd row, so it can't do an expanded octet, so it can only have 8 electrons. So carbon has 2, 4, 6, 8 electrons. It is satisfied. Hydrogen has 2 electrons, 2 electrons, 2 electrons, 2 electrons, so it is satisfied for the maximum electrons it can have. But here oxygen has 2 and 4 electrons bonded to it. Now remember, I have 4 electrons left over, so I'm going to put lone pairs on my oxygen with those electrons that are left over. And now I have 2, 4, 6, 8 electrons on my oxygen, and this completes my Lewis diagram. Step 4, make double or triple bonds to satisfy octets if available electrons are all used, and we don't have that, so we're good. We don't need to do that. So let's try a different one. We have CH2O, and again I have carbon. Carbon has 4 electrons. I have 1 of them, so that's 4. Hydrogen has 1 valence electron. I have 2 of them, so that's 2 electrons. And then oxygen has 6 valence electrons. I have 1 of them, so that's 6. And I have 12 electrons on this. So the first thing I'm going to do, again, carbon is my least electronegative, and I'm going to put that in the center. So I have oxygen, hydrogen, and hydrogen. Let's count how many electrons I've used so far. 2, 4, 6. So I've used 6 electrons here, which means I have 6 electrons left over. So I need to use 6 more electrons. So again, hydrogen. Oops. So I'm going to put my valence electrons here. So now I have 2, 4, so let me see, 2, 4, 6, 8, 10, 12 electrons. So I've used all my electrons. So I have 12 electrons, so I'm good. So now I need to do step 4. Do all of my bonds satisfy the octet rule? So hydrogen has 2, so that's good. This hydrogen has 2, so that's good. Oxygen has 2, 4, 6, 8. Great, it satisfies the octet rule. But carbon has 2, 4, 6. So carbon does not satisfy the octet rule. So what I'm going to do that is it says make double or triple bonds to satisfy octets if available electrons are already used. So they've all been used. So what you do is you transfer a set of these electrons. So you transfer that to make a double bond. And it looks like this. So now I have a double bond, and my oxygen has 2 lone pairs because I used this lone pair here to create my double bond. And now I'm going to go back and check. I have 2 on my hydrogen, 2 on this hydrogen. Carbon has 2, 4, 6, 8. That's great. And oxygen has 2, 4, 6, 8. So this works. I've satisfied my octet rule on all my atoms, except again, hydrogen, let's write that down, can only have 2 electrons, right? Okay. Feel free to pause this video and try some of these on your own. Otherwise, I'm just going to keep going. Let's do NO3 negative. So nitrogen, that's a new element for us. So let's go back to our periodic table and look. Nitrogen up here. Nitrogen is here, and it has 5 valence electrons. So nitrogen has 5 valence electrons. I have 1 nitrogen, so that's 5. Oxygen has 6 valence electrons. There's 3 of them, so that's 18. And then I've got this negative here. That means there's an extra electron, so I have to add that one too. So if I add that together, I get 20, so I'll just put electron. I get 24 electrons. So let me draw my skeleton structure. If I look on my periodic table, nitrogen is the least electronegative, right? Because oxygen's further to the right. So I'm going to put nitrogen in the center, and then I'm going to put oxygen on all my sides. And with that skeleton structure, I've used 6 electrons, and that means I have 18 electrons left over. So now I'm going to add all my remaining electrons to my oxygens. So I've got lone pairs, and I'm just going to draw around. So I've got 6, 10, 12, 14, 16, 18, 22. Am I counting that right? I think I counted too much. Let's try that again. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I've counted all my electrons. They're all accounted for. And oxygen, each oxygen has 2, 4, 6, 8 electrons on it. So that's great. But my nitrogen here has 2, 4, 6. So it has not satisfied the octet rule. Now, I need to borrow a lone pair from one of these oxygens, and it doesn't matter which one it is. You can take any of the oxygens. It will create a resonance structure, and we're going to talk about that the next unit. But we'll just take it from this oxygen and put it here on the nitrogen. So now I've got a double bond with one of the oxygens. And I'm going to still put my lone pairs. And then I'm going to keep my other oxygens with all of the electrons around them. And then if I check again, I will see that nitrogen has 2, 4, 6, 8. Oxygen has 2, 4, 6, 8. And both these oxygens has 2, 4, 6, 8. And then you can double count or go back and count and make sure you still have 24 electrons on everything. But you'll see that you do. The other convention is that when we have a negative charge, we put brackets around the molecule and we put the negative there just to indicate that there's an extra electron there, that it's an ionic molecule or it has a charge, okay? It has an ion charge. I shouldn't say ionic, but it has an ion charge. Let me correct that. Okay, let's do this last one. Xenon fluoride, okay? And xenon, that's interesting. Where is that? So xenon is here. It has 8 valence electrons. And fluorine is here, and it has 7. Okay, so let's do this one. So I have xenon. It has 8 valence electrons. I have 1 of them, so I have 8. And then fluorine has 7. I have 4, so that gives me 28. So if I add that together, I have 36 total valence electrons. Now the first thing I'm going to do is draw my skeleton structure, and I'm going to attach all the fluorines to it. Xenon is the least electronegative. If you'll see, xenon is, remember, electronegativity increases as we go up, so xenon has lower electronegativity. Oops, come back. So now I'm going to count. I've used 2, 4, 6, 8. I've used 8 electrons, just with my skeleton structure, 2, 4, 6, 8. And that means I have 28 electrons left. 28 electrons remaining. Okay, that I need to add. So I'm going to go back here. I'm going to add all my fluorines. And I'm going to put 8 electrons around each, or 6 around each, with my bond. Remember, we put the lone pairs like a little box. We put 2 on each side of our square. And then I'm going to count. So I have 2, 4, 6, 8 times 4 gives me 32 electrons. But I need 4 more electrons. So right here it says place the remaining electrons to fill as many octets as possible. And then if there are still leftover electrons, place them on the center atom. Remember, it has to be past the 3rd period. So I need to double check that xenon is past my 3rd period, and it is. It's down here. 1, 2, 3, 4, 5, so it's in my 5th period. So I can put the remaining electrons on the central atom, and again, we show those paired up. So I'm going to make room for these. 1, 2, 3, 4, 5, 6. And this one will make what we call an expanded octet. So to get good at this, you just have to practice. Make sure, so now I'm going to add 2 here and say 2 here. And just make sure you pair them up and then count that you have 36 electrons total. But yes, drawing Lewis structures just takes practice, just doing a lot of examples, and then it becomes what I would say fun and pretty easy. So just good luck with that, and watch this again for if you need help.